In early 2023, the James Webb Space Telescope peered into the universe's infancy and found something astonishing: 6 massive, mature galaxies existing just 500 to 700 million years after the Big Bang. These weren't the faint baby galaxies we expected, they were giants, as massive as the Milky Way is today. Imagine looking at a photo of a newborn and seeing a fully grown adult staring back. That's the scale of this surprise. This discovery, made in a tiny patch of sky, challenges the very foundations of our cosmological models. The universe, it seems, built galaxies far faster and more efficiently than we ever imagined. The data came from Webb's first deep-field observations, capturing light that traveled over 13 billion years to reach us. When astronomers analyzed this light, they were stunned by the sheer mass and maturity of these galaxies. According to our best theories, the universe simply hadn't had enough time to build such monsters so quickly. It's like finding a skyscraper built in a week. This isn't a minor tweak to our understanding, it's a potential revolution. Every textbook on galaxy formation is now under scrutiny, as the universe proves itself more creative than we ever gave it credit for. Our leading theory, the Lambda CDM model, describes a universe where galaxies grow slowly, merging over billions of years. After the Big Bang, matter clumped together gradually, forming small proto-galaxies that would eventually merge into larger ones. This model sets a speed limit on galaxy formation. Building a Milky Way-sized galaxy should take billions of years. If we looked back to 500 million years after the Big Bang, we expected to see only small, chaotic baby galaxies. But these 6 galaxies ignore that speed limit, converting nearly all available gas into stars with impossible efficiency. It's like baking a cake in 1 minute instead of hours. Either our understanding of the ingredients is wrong, or the process is happening in a way we never imagined. This finding doesn't just challenge galaxy formation, it shakes the foundation of our entire cosmological framework. If galaxies can form this fast, maybe there was more matter available, or perhaps dark matter behaves differently than we thought. These 6 points of light have become a focal point for a potential crisis in cosmology. A beautiful problem that could lead us to a deeper truth. Before Webb, the Hubble Space Telescope gave us our best look at the early universe, but it could only see invisible and ultraviolet light. Because the universe is expanding, light from the earliest galaxies is stretched into the infrared, beyond Hubble's reach. Hubble's images showed us small, clumpy blue galaxies, cosmic babies, just as our theories predicted. These galaxies were chaotic, filled with hot young stars, and matched our models perfectly. We thought we had the story of cosmic dawn figured out. So when Webb looked deeper, astronomers expected to see more of these baby galaxies, just in sharper detail. Instead, Webb found massive, red, and surprisingly mature galaxies coexisting with the faint blue dots. They weren't babies. They looked like teenagers who'd already reached their full height. The discovery didn't just add a new chapter, it ripped out the old pages and demanded a complete rewrite. Our elegant theory suddenly didn't fit the evidence. The universe's early years were far more dramatic than we ever imagined. Webb's findings have forced us to rethink everything we thought we knew about the cosmic dawn. The key difference in these galaxies is their color red, not blue. In astronomy, blue means young and active while red means old and settled. These 6 galaxies are not just massive but unexpectedly mature and red, suggesting they've already finished their main star-forming phase. How could a galaxy form, burn through its star birth, and settle down in just a few 100 million years? It's like meeting a 5-year-old who's already retired. Even more puzzling, these galaxies are incredibly compact, cramming a Milky Way's worth of stars into a much smaller space. To form so many stars so quickly in such a small volume defies our models. The intense radiation from the first stars should have blown away the gas-halting star formation long before such a massive galaxy could be built. Instead of nurseries full of newborns, Webb found what looked like fully formed adults. This is the heart of the universe breaker problem, a direct challenge to our best theories. The evidence is clear: the early universe was far more efficient and dramatic than we ever imagined. Faced with this cosmic mystery, scientists are scrambling for answers. Maybe we're misinterpreting the data, perhaps these aren't galaxies but something entirely new, like supermassive black hole stars. Or maybe the rules of star formation were different in the early universe, with the first stars being hundreds of times more massive than our sun. Such behemoths could have accelerated galaxy growth dramatically. A more radical idea: our entire cosmological model might need an overhaul. Perhaps dark energy or dark matter behaved differently in the early cosmos, allowing structures to form faster. Ultimately, we need more data. Webb's first deep field image found 6 of these objects, but as it continues its mission, it will find hundreds more. By studying a larger population, we'll learn if these are rare outliers or a common pathway for early galaxy formation. Each new observation is a clue helping us build a new, more accurate story of our cosmic origins. The mystery is just beginning, and every answer will lead to even deeper questions. The James Webb Space Telescope, or JWST, is the most ambitious space observatory ever built. It's a joint project between NASA, the European Space Agency, and the Canadian Space Agency, and sits 1.5 million kilometers from Earth at the L2 point. Webb's mission is to see the universe in infrared light, crucial for studying the earliest galaxies and peering through cosmic dust. Its giant mirror and advanced instruments allow it to capture faint, ancient light invisible to Hubble. The telescope's 5-layer sun shield, the size of a tennis court, keeps it cold enough to detect the faintest signals from the edge of time. Webb's 4 scientific instruments, NIRCam, NIRSPEC, MIRI, and FGS NIRIS, make it a versatile observatory. It can study everything from the first galaxies to the atmospheres of exoplanets. Webb is not just a telescope, it's a time machine and a microscope, revealing the hidden universe. Its mission to rewrite our understanding of the cosmos. Webb's most iconic feature is its golden primary mirror, spanning 6.5 meters, the largest ever sent to space. Made of 18 hexagonal beryllium segments, it folds up for launch and unfolds in space with microscopic precision. Each segment is coated with a thin layer of gold, reflecting over 99% of infrared light. The total gold used is just 48 grams, about the mass of a golf ball. This golden eye allows Webb to capture precious photons from the edge of time. The 5-layer sun shield made of ultra-thin Kapton keeps the telescope frigid and blocks heat from the sun, Earth, and Moon. This passive cooling system is essential for Webb's infrared vision. Webb's design is a triumph of engineering. A golden eye protected by a silver shield, floating in the dark. It's the most powerful tool we have for exploring the universe's earliest moments. The universe-breaker galaxies are just the beginning of Webb's scientific mission. Webb is revolutionizing our search for life by analyzing the atmospheres of exoplanets using transit spectroscopy. It's already detected water and carbon dioxide in distant worlds, and is studying the TRAPPIST-1 system's potentially habitable planets. By studying these atmospheres, Webb could reveal whether the building blocks of life are common across the galaxy. Beyond exoplanets, Webb will peer into star-forming regions, study the life cycle of stars, and investigate dark matter and dark energy. It's a time machine to the dawn of the universe and a microscope for cosmic details. Webb's mission is to rewrite our textbooks, and it's only just begun. Every new discovery will reshape our understanding of the cosmos. The future of astronomy has never looked brighter. The discovery of 6 massive galaxies in the infant universe marks a fundamental shift in our cosmic story. For decades, we believed in a slow, methodical universe. Webb has shown us a cosmos in a hurry. This isn't a failure of science, but its greatest triumph. New data shattering old models and opening new frontiers. The universe-breaker galaxies are a beautiful problem, inspiring new theories and perhaps even new physics. Webb will continue to scan the skies, finding more enigmatic objects and helping us choose between competing explanations. Are we seeing supermassive black holes, a new kind of star formation, or do we need to revise our entire cosmological model? Every discovery reveals a new layer of the unknown. The universe is more wonderful and surprising than we ever imagined. The James Webb Space Telescope is our vessel into the unknown, and the adventure of understanding our place in the cosmos has only just begun. The maps are outdated, it's time to draw new ones.